Hi, here we are. We're going to do Chapter 10, Homework 11. So today in class we talked about density, and there were two formulas we worked with. There's not really a lot of space on here to do my work, so I'm just going to use some copy paper or notebook paper. Density is mass over volume. Now, if I'm dealing with population density, that's a little different. That's the number of people I have in the space, and then I want to divide by the area. And so both of those work depending on what I'm dealing with, okay? Now, it's important to think about how they talk about these things. So sometimes when they talk about mass, they're talking about weight. So a lot of times it's measured in grams or kilograms or pounds, something like that, okay? So that's how we measure mass. Volume. Well, volume has a whole lot to do with geometry, doesn't it? Should kind of ring some bells. So volume, they might tell you, and volume is a three-dimensional thing. So it's three-dimensional, therefore usually it has centimeters cubed, meters cubed, feet cubed. They also say the words cubic centimeters, cubic meters, cubic feet, cubic inches, right? If it's liquid, we don't think of it as inches or centimeters cubed. We think it as milliliters, okay? But those are all ways to measure volume. How much did it fill it up? How much space does it take up in the universe? Okay, so with that general idea, let's go ahead and do question 1. It says a student measures the mass. Okay, so the mass is 8 centimeters. And it says that measures the mass of an 8 centimeter block to be that. So it sounds like the mass is actually this. And so notice how the review of what we set up here is important, because kind of the way they say it looks like mass is this, but if I read, they're saying the mass is actually 4.49. And the block itself is 8 centimeters cubed. So kind of using this as a guide, they really are telling me the volume, because that's what centimeters cubed means. So they want me to calculate the density. Well, density is mass over volume. So density is the mass, 4.49, over the volume, 8. And that our answer would be in grams per centimeter cube. So I typed this in the calculator, and I don't have my calculator on me. Hold on one second. I don't have my calculator, so you're going to have to figure out what that is. I didn't type it in, and apparently I can't make a video and use my calculator, so you'll have to come up with a final answer, and the answer will be in grams per centimeters cubed. Awesome. Okay. Question 2. It says determine the weight. So we know the weight is the mass. So the mass is what we don't know. And it says determine the mass or the weight if I fill it. And so that's the volume, 300 milliliters. And the container has a density of 0.789 grams per milliliter. So once again, this helps me out that density is equal to whatever the grams are divided by the milliliter. So if the density is equal to mass over volume, and we know the density is equal to 0.789, we don't know what the mass is, but we know the volume is 300. So we look at this equation and we say to ourselves, how can I get m by itself on one side? So some folks like to cross multiply. Other people would just multiply 300 on both sides, and they'd both be right, correct? So we get m is equal to 300 times 0.789, which I calculated to be 236.7 grams. So I solve for mass, which means my units should be in mass. Okay. Next question. Question 3 states, if a certain block of lead has these dimensions, and it's a rectangle prism. So they're basically telling you the volume, because essentially the volume of a rectangular prism is base times width times height. Or you could think of it as length times width times height. And lucky for you, they gave you all three: the length in inches, width in inches, the height in inches. So this is going to be in inches cubed. And so in essence, this falls in line with what we think of as volume. So if I multiply these together, I get 140.4 inches cubed. Now I'm not solving for volume. I'm actually solving for density. It says determine the density. So we know density is equal to mass over volume, correct? And we know the volume because we just calculated it. So the volume is 140.4 inches cubed. Now our mass, let's look back in the question. It says it weighs 1587. So that has to be our mass, 1587 grams. So we say to ourselves, okay, 1587 grams. And it should be pretty easy to calculate our density, and our density answer would be in grams per inches cubed, right? So if I divide these two numbers, I get 11.3 as my density. Looking good. Okay, let's look at question 4. It says, a cool science teacher performs a demonstration and finds that the cork displaces that amount of water. So that must be our volume, because we know volume can be measured in milliliters, okay? Now it says not only does it displace this amount of water, but it weighs. So that must be our mass. The weight is 5.7 grams. So we know to find density, the density is equal to mass over volume. And we also know from previous problems that most of the time we calculate it in grams per, and we can calculate it in grams per centimeter cubed, or kilograms per feet cubed, anything like that, any of mass and any other measurement. So here I'm doing that in milliliters. Okay, so I have 23.5 milliliters and I have 5.7 grams. So my density ends up being 0.243 grams per milliliter. Okay, I'm feeling very sciencey with this lesson. Now we continue with question 5. Now I actually put this together before, so you may want to pause it to get some of the pictures, because there's a lot of ideas kind of floating around. Okay, so I'll read the question to you guys. And if you want to draw the pictures, great, pause the video, because it's kind of cool. It helps some kids kind of understand what's happening. So it says in the problem, an empty graduated cylinder has a mass of 50 grams. A cylinder has a mass of 120 grams when somebody put 30 milliliters of water in it. So this has 30 milliliters of water in it. Then a rock, when they added it, rose the level of the water. And the rock, when added to it, increased the mass. So now that's 250 grams. And it also increased the amount of water in there to 75 milliliters. Okay? So to continue our thinking, I think it's, hopefully if you walk through the mental steps here, the fluid's weight must be 120 grams because the empty cup already weighs 50. So just the weight of the water is 70 grams. The rock, using this same idea, if just adding the rock made the weight go up to 250, then the rock itself must be 130 grams. Now we know weight is basically mass, as we've been talking about before. So now let's look at the rock's volume, because the volume that the rock displaces, it was 30 and now it's 75. So it should, if we think this through, we're thinking to ourselves, the rock must have been a volume of 45 because the volume went from 30 to 75. So we also recognize that if the only thing in here is fluid, then the fluid's volume must be 30 milliliters. So I believe we have all our ingredients to find what they've asked. They'd like us to determine the density of the rock. So let's take a look. The density of the rock should be mass, or the weight of the rock. So we found the weight of the rock to be 130 grams, divided by the volume of the rock, which we found to be 45 milliliters. So I got the answer 2.9 grams per milliliter. Pretty cool question. I'm feeling very scientific right now. Okay, last question, and I'm also gonna just kind of lead you through this here because I already wrote out my answer. So let's walk through 6. As I look at question 6, I say to myself, below I see a table of different types of solids. So in A, it says, while digging in the backyard, I find a coin whose mass is 26.7 and the volume is 3. So this is like my Florida question in class. I pretty much am just going straight to calculating the density. And I noticed that this matches copper on the table. Hopefully that's similar to what you got. Okay, so maybe pause the video, calculate B, and see if it matches. In B, it says a paperweight, which is rectangular, has a volume, and if we multiply these together, that's our volume. Okay, so that's our volume. It also says that this is the mass. So mass divided by volume would be the density, and that matches marble. So hopefully that matches what you got. Okay, part C says, playing in a play put of a restaurant, you find a ring. The mass is 107, the volume is 5 milliliters. So I get an answer, 21.4 grams per milliliter, and that happens to match platinum. Pretty neat. Okay, D, last but not least, let's see if we found a diamond. The mass was 528. The volume was 2 cubic centimeters. That unfortunately matches quartz, not diamonds. Thanks for joining us. Look forward to seeing you tomorrow.